Hi guys, we are here today to do our section 3.5 practice problems. This section is number of solutions. That's the one I told you I was super excited about. So I'm excited to be doing these problems today. Nothing I love more than solving equations. It's my favorite thing. Solve each equation. Determine whether the equation has one solution, no solution, or infinitely many solutions. Okay, thinking back to the lesson, remember that if you get down to, if you look at the equation and you see that if you're able to solve it for the variable, it has one solution. If you get down to where you have a false statement, it has no solution. And if you get a true statement, then that means it has infinitely many solutions. So let's solve these two problems and see how they turn out. First of all, they're pretty messy. I can't tell if the left side and the right side are going to equal or be the same or anything. So we've got to clean them up. Let's use our distributive property to get rid of some parentheses here. 4 times x is 4x. 4 times negative 8 is negative 32 plus 12. Over here, 2 times 2x is 4x. And 2 times negative 9 is negative 18. We could do some combining like terms here. All right, we have 4x, a negative 32, and a positive 12 gives us a negative 20 equals 4x minus 18. Now, you'll notice that your variable terms are the same, but your constants are not. Okay, so this is one of those special cases. If you aren't sure which one, you can keep solving it, but you might be able to tell at this point that the left side and the right side are never going to be equal. The left side's always going to be 2 less because you're subtracting 20. You're subtracting 20 on the left and 18 on the right. It's okay. If you want to go ahead and get rid of the variables, go ahead and subtract 4x from both sides. But if you can tell at that point, you can quit there. Now I've got negative 20 is equal to negative 18. Guess what? That's a false statement. So that means we have a situation that has no solution. Okay. These two lines, if you graphed, no, I don't want to say that. Never mind. All right. I don't want to go there yet. This one, we want to get rid of parentheses first. So we're going to distribute, 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 distribute. 3 times 2k is 6k. And 3 times negative 5 is negative 15. 6 times k is 6k. 6 times negative 4 is negative 24 plus 9. Now we need to combine like terms. We've got a negative 24 and a positive 9 here. We have 6k minus 15 equals 6k, and guess what? Minus 15. These are identical. These will always be equal, okay? So this is going to give you a true statement. You don't believe me? Subtract 6k from both sides. You got negative 15 equals negative 15. That is a true statement. So this has infinite solutions. The left and the right side were identical. Okay. Pretty fun. I'm liking it. This is on page 167. Ooh, they're starting to put a fraction. Got a fraction one. I love fractions. All righty. So we have, I could kind of move this over just a smidge. Yeah, that'd be better. All right, we want to tidy this up. I noticed the left-hand side of this equation is already neat and clean, so we're just going to leave it the way it is, but we got to fix this right side. Distribute the 1/3. 1/3 of 12. Well, think about it. If you divided 12 into 3 parts, you would have 4, wouldn't you? So 1/3 of 12 is 4y. 1/3 of 9 is 3, so it would be minus 3. And then we have minus 8y. Ooh, we need to combine like terms. We have a positive 4y and a negative 8y. Well, let me rewrite the left-hand side. What do you get when you combine a negative 8 and a positive 4? You get negative 4y minus 3. And what do you notice about the left and right side? They're identical. All right. If you don't believe me, add 4y to both sides. And you got negative 3 equals negative 3, which is a true statement. which means you have infinite solutions. Number 4. Oh, messy on both sides. Distribute 6 times 3 is 18. 6 times negative 5w is negative 30w. Then we get to the equal sign. Distribute on this side. 5 times 4 is 20. 5 times negative 2w is negative 10w. And then we have this straggler over here, this minus 20w. Okay. On the left, we have 18 minus 30w equals. All right, there's no one to combine with the 20, but we can combine a negative 10w and a negative 20w to give us negative 30w. Now, at this point, you will notice that this is not a true statement, okay? This hasn't, both of the 30s are the same. So that number is going to be the same, but this side only has 18 and this side has 20. This side will always be 2 bigger than this side. It's never going to balance. Don't believe me? Add 30w to both sides, and you will have yourself a false statement because 18 is not equal to 20. All right, that's false. So this equation has no solution. All right, we are zipping through these. Okay, complete each equation so that it has infinite solutions. I love these. These ask you to challenge yourself. And this is exactly what you'll see on the air test too. They put ones like this on there. All right, they want you to create an equation that has infinite solutions, which means your left and right sides have to be identical, okay? But this is a mess. So we have to straighten this out before we can figure out what we need to put in these boxes. The 2x is just a hanger-oner. The number we're distributing is this negative 7. Negative 7 times x is negative 7x, and negative 7 times positive 10 is negative 70. All right. Combining like terms, 2x minus 7x is negative 5x minus 70. Well, if you want the left and right sides to be identical, then we need to have identical, negative 5x minus 70. And that would be the correct answer to that, right? Same thing over here. We don't have any parentheses, but we do have terms we can combine. We have a positive 12x, a negative 1x, and a positive 3x. Well, 12x minus 1x is 11x, and 11x plus 3x is 14x. And then there's no one to combine with the 8. But remember, we want the left and right sides to be identical so that we have infinite solutions. So we must have 14x here and a positive 8 here. Okay. Love this. Now, this asks you got to read the directions carefully, guys. This one says complete each equation so it has no solution. So when we have no solution, that means that our variable terms are the same, but the other numbers are wrong, okay? That will make no solution. The variable terms have to be identical, but the other numbers have to be not identical, okay? So let's combine some like terms here. We have a negative 15x, a positive 4x, and a negative 1x. So negative 15 plus 4 is negative 11, and negative 11 plus a negative 1 is negative 12. So negative 12x, and then we have a plus 2. Now here you have some choice. This has to be negative 12x. This number can be any number except 2. All right, it could be 3, it could be 4, it could be a half, it could be negative 374, any number you want, but not 2. Okay, so we'll just make it 3. Now the right side will always be one more than the left side. It will have no solution. Now I don't know what these are going to look like in Reveal. I haven't created the practice assignment, but I want to say they're probably going to be multiple choice. Okay, because there's no way for them to be able to grade this accurately, so it's probably multiple choice. Let's do this one. Distribute. 9 times x is 9x. 9 times negative 4 is negative 36 minus 5x. Okay, we're going to combine like terms. This is a positive 9x and a negative 5x. which is going to give us a positive 4x minus 36. So they want this to have no solution, so the variable term must be the same, and this number has to be different. This number can be any number except 36. I did it. Okay, which of the following explains why this equation has no solution? All right, super fun. What we're going to do is we're going to simplify this thing so we have a better idea why it has no solution. Okay, let's see. 2/3 times x is 2/3 x. And 2/3 times 3 is 2. 2/3 of 3 is 2. 2/3 times x is 2/3 x. And 2/3 of 6 is 4. So, which explains why this has no solution? Now, you have to know your terminology. Coefficient is the number in front of the x. These are your coefficients. Constants are these other numbers, the regular old numbers. Those are your constants, okay? So this does have no solutions. The variable terms are identical, but the constants are different. So which one of these says the coefficients are the same and the constants are different? Coefficients are the same, constants are different. D is our winner. Okay, suppose the solution to an equation is x equals 0. Explain why it is incorrect to conclude that the equation has no solution. 0 is a whole number. 0 is a solution. A lot of equations end up with x equals 0. It doesn't mean x has no solution. It means x is 0. Okay, 0 is a number. And that's all I'm going to ask of you in this section. So, pretty short video. You've got plenty of time to go over to McGraw-Hill and get that practice assignment done and do a nice job on it, because remember, this is my favorite section. And if you have any questions, please ask.